assignment, but I have time to go over it.
Yeah, I kind of looked at it and was looking at the Google Earth thing, but I wasn't 100% sure on what we're supposed to do. So,
Okay, let me pull it up. Because I think for the Google Earth part, I think that I have a file similar to that from the lab that I can pull up.
okay.
So instructions. All right. I think I know it. I think I have it still. Let me just look for it.
Okay.
I don't think I have that anymore.
Okay. Well, I might just not know how to do it. And maybe that's why I didn't understand what we were supposed to do. Because when I
Yeah, it's why if we.
go ahead, sorry, what?
That's why did he post somewhere? Uh, um, the KMZ file.
It was no, well, if you like go to just the like home page, so if you click on the geology title where it takes you to the announcement, he puts a USGS KML file, but it's not really anything from what I
Yeah.
can see. But then he like lists other versions too, so I'm not sure exactly. Um, I'm thinking that maybe I just don't know exactly how to work this Google file thing for the assignment we're supposed to do because looking at it, I don't see anything. And so I don't know what it is that we're supposed to do.
Yeah. Okay, let me look again. Well, so we did this before. The first week of the lab, some had to do with it had to do with all of this. Let's see. Okay.
I think I might have found.
So I found right here. Let me present it. Okay. This this shows the depth of the earthquakes, and also then it has the plate boundaries.
Oh, cool. So yeah, I figured out the depth. So I got the depth one for the Mariana Trench. And so from there, we're supposed to mark them, or there's a lot of earthquakes over there.
Let me see. All right. Plot. This is interesting. So plotting, like, are we supposed to replot them on the Google Earth, or just look at it?
It kind of almost looks like we're just supposed to look at this and then answer the questions. I don't think that we have to do like what we've done the last couple of weeks where we've made notes based on the image, like notes on the image. I think we just have to answer the questions based on the image, like looking at it. Okay. Does that make sense?
Yes.
Okay.
So there's the trench right here.
Oh, whoa. Yours shows way more than mine does.
Yeah, so I think this is the last 30 years.
Oh, 30 years?
Yeah.
Oh, okay, mine was the last 30 days.
For 30 years.
Wow. That's cool. I'm going to close mine because I don't want to look at mine anymore. I want to look at yours.
Yeah, so this is one that we can use to look at, get a little bit more of an idea, because it said run up, how it runs up also to up to Japan.
Mm-hmm. Is there a plate boundary right there?
Yes, I think this right here. I think this is a convergent one right here.
Mm-hmm.
And this one is a divergent. Yeah. So that's the Pacific and Philippines. So this one is a convergent. Let's see.
So all of these earthquakes are from the movement of those plates.
So yeah, so here, that's the Mariana Trough. That's It's a divergent right there. Yeah, so that's the Philippine. Okay, so looking at this, along here, but it's also then it's a convergent right here. So I think what's happening is this is Pacific plate, right? Yeah. So I think this is the Filipino plate right here. And then this one is the Pacific. And so what this is telling us is that the Pacific plate is subducting underneath all of these other plates up along here.
Pacific is subducting.
Because as the Pacific plate goes down, like what we were talking about a couple weeks earlier, how as it goes down, it'll hit that point where it'll start melting further inland.
Right.
And that's for volcanoes, but then also for earthquakes, it's sort of that same thing. So they'll have the friction that'll down here. So as it dips in, the friction further down, it will start to that friction plate, and then it'll snap. And that's because this is all of the epicenters or the focus,
right,
where it is in the depth.
Most of them look like they're just between 0 and 33.
Yeah.
Some of them are deeper, but most of them are 0 and 33.
Yeah, except down here, we have all these deep ones too.
So most of the quakes along Japan are 0 to 33?
Yeah, 33 to 70. Well, I wish that we could turn off some to be able to look at a little bit better. Because okay, so there isn't any blue ones underneath. Yeah, so there's tons of these. That one's what, 10 kilometers deep? These little white ones are.
Oh wow!
I think so.
And then where did those purple ones? They were along what?
Deeper over here. So my idea is if we look, they kind of ones, they seem like they're further inland from the, not inland, I'd say further in from the plate boundary. Because right here we'll have those, a lot of those 30, the 0 to 33s. We start getting to the 70, 150s, 150 to 300, and then the deeper ones right here.
So the further away from the plate boundary, the deeper the earthquake occurs.
Yeah, because we can even look right here. All the big ones. What is, let's see. Maybe turn off some of these other. There we go. Now let me try and find the plate boundary names up.
Okay. So.
These, yeah, so these are the plate boundaries. These different, oops, too far. So there's a plate right there.
There's like no earthquakes happening there.
And here's a small plate. So I think the red one thing is the divergent boundary right there, and then those are convergent.
Mm-hmm.
Yeah, so I believe that this is all convergent all the way along here. Another one. Yeah, because I know right here that's convergent, so.
So is this stuff that you've all plotted in your other class, your lab class? Or is there set it up that it already is there and you just select that information?
This one was already set up. I think they just download the link for us from GS website, but we haven't plotted any of this.
Interesting.
But I did learn my GIS class how I could plot something like this,
mm-hmm.
and then be able to upload it into Google Earth.
Wow, that's crazy.
Cool. So, yeah.
All right, so some of the notes that I've taken so far is that the Pacific Plate is subducting under all of the other plates right there in this area. The further in from the plate, the deeper the earthquake occurs. Most of the earthquakes along Japan are between 0 and 70 kilometers deep. Further in from the plate boundary, we have a long line of 300 to 500 kilometer deep earthquakes.
Yeah, because even up here you can see there's those deep ones. Yeah, so I'm guessing, yeah, the focus, like what we talked about on the reading. So it's what's in the ground. I think the epicenter is on top of the ground, and that's what they do with the different triangulation, where they take the distance that 3 different places have picked up who have felt the shaking. And then they draw the circles around it, and that top part is the epicenter, and then down below. And so this is mapping out the focus.
And so that's why they're different sizes.
So the different sizes is the magnitude of it.
Oh, okay.
And then the color is the depth. So yeah, so it's analyzing 2 different things. The 2 of it. So it's, yeah, because you can see here, looking at, there's this one that's bigger. Zoom in. Yeah. So how this one, even though it's a different color, this was a 7.1, and this one's a 4.
Okay.
Yeah, and so it's interesting because even then, another kind of observation is further in, it doesn't necessarily mean that it's a bigger magnitude. So like they're right about the same as these ones. So these ones are all around the 6s right here. And even out here, they're in the 6s as well.
That's interesting.
Yeah, because you have this one way only 4.2. And then we have that huge one right here. Here's the Here's on if we can get on the 9.1 that happened a couple years ago. So yeah, so that's another observation we can put in is depth of focus doesn't correlate with magnitude. Oops. All right. Zoom out. Let's look at the Himalayas. So here's that. You can faintly see the plate boundary here. So the India plate slamming into the Eurasian plate.
Okay.
So all these right in here, this is all the Himalayas. This is the plateau of Tibet. And so again, we see it where on that boundary. Let's see, better find it. So I think this you can tell with the smaller screen, but it looks like there's a faint boundary right here.
Okay.
I think that is it happens. That's the plate boundary, and so and it lines up pretty much to that first range.
Mm-hmm.
But yeah, you can see. I think I don't know. Let's look it up just to be sure. But the continental to continental plate, if one's subducting, then definitely India, and that because all of these earthquakes have happened on this north side in the Eurasian plate. So let's even look. Let's throw on some volcanoes and see if they have any in there.
There's definitely less earthquakes over here. And the depth doesn't go as deep compared to the Marianas Trench in Japan.
Yeah, exactly. Yeah, except for this one part up here.
Oh yeah, I didn't see
Up in that was Pakistan, Afghanistan, right up above it. There were a bunch right here in this region of the Hindu Kush, and they're very deep as well. So I think that's the one. It seems like that's the one outlier that we have.
Yeah.
Is this over here, Kush. But yeah, other than that, they're all relatively very shallow. But we do get a lot of those that they're still pretty big on the magnitude.
Mm-hmm.
Get a little bit deep ones. This one is also an odd one. Whatever plate this one is, or I guess it's still the same to these far out ones, but we get these deep ones right here.
Mm-hmm.
Which is interesting because they look like they're on the India side.
Right.
But I can't tell for sure the Eurasian plate or not down here. If that's a new plate or not.
Mm-hmm.
But
And what did you say? What plate was subducting?
I believe the India one is subducting. Let me double check. Yeah, so the India plate is subducting. Okay. Then
So when the earthquake is deeper and it has the same magnitude, you don't feel it as much, right? Or is that magnitude based off of what they feel?
trying to let me pull and just see. I'm trying to remember the difference, the magnitude and the intensity. I don't know if intensity. Yeah, I just need to see. I can't say for sure. Because I think also with how much they feel it, it also depends on what the material's made out of. Because there's softer, less compacted material or soil that is in that area, then they won't feel as much or it won't spread out as far. Because it will kind of cushion it a little bit more, and then if it's dense, it'll spread out further. Because they talked about the San Andreas fault, and then also the earthquakes over in the Midwest. How over in the Midwest they have a lot more solid bedrock, and so waves go through here. Let's see. Earthquakes. Okay, so is a measure of the amount of ground shaking at a particular location based on observed property damage. Seismographs allow the scientists to measure ground motion using instruments. This quantitative measurement, called magnitude, relies on gleaned from seismic records to estimate the amount of energy released at the earthquake source. So
Earthquake source. So then if it's deeper, then it doesn't do as much damage on the surface, right? So if the source is 150 kilometers versus 33 kilometers, it won't do as much damage.
maybe.
That's what I'm understanding.
I don't know for sure, because we have. Okay, because you're looking at the intensity. That's what shows how destructive it is.
Intensity is destruction.
Yeah. And magnitude is just how much energy was released.
Okay.
Because there's a 6.3 right here that's 70 to 150, and a magnitude of 6.2.
Uh-huh.
That's only 33 kilometers deep.
So I'm thinking the deeper, since those two are like the same magnitude, but one is deeper than the other, that deeper one doesn't do as much damage on the surface. Am I understanding that right? Am I thinking correctly?
Yeah. So I don't know if I can for sure say that it would do as much damage on the surface, because I feel like there's different things that go into damage. Because if you look at, like, compare Afghanistan to like California. California is ready for these earthquakes, but I don't know if in like
Okay, yeah.
if there's any of these other places where they aren't as developed and they don't have rebar enforced like masonry.
Right.
There could be a smaller magnitude, but it could destroy a lot more.
Right.
So I think this is pretty much showing us is that the depth doesn't correlate with the energy. So even though it's deeper, it can still let out the same energy as something that's 0 to 30, that's at only 33 kilometers deep.
Right.
If that makes sense.
Yeah, no, I understand what you're saying.
And I think that would be a good way to put it, is just tell them, based on this map and the data that's given to us, we can't tell what the intensity is, but based off of the depth and magnitude, we see that depth doesn't correlate with magnitude, isn't directly correlate, well, isn't in a direct relationship with magnitude and depth are not, there we go. Magnitude and depth are not a direct relationship. The direct relationship would say, like, either the deeper you are, the more magnitude there is, or the shallower, the more magnitude. It'd be one of those.
Right.
Where it'd be linear, but it's not. Yeah, this far boundary, that's an interesting one, because we have some on both sides, and we even have volcanoes on either side of this plate boundary.
We're really close too.
Yeah, so I think that would be a good, if it asks us if we needed to come up with any questions, but so okay. I think we do we answer all the questions?
Let's see here. Okay, do we talk about, so it says plot the depth of the earthquakes against the distance along the surface and note the size of the earthquakes as well. So, well, we kind of talked about that. We talked about the further in, the deeper the earthquakes occur. It says plot the depth of the earthquakes against the distance along the surface and note the size of the earthquakes as well. And basically, there's only a couple, there's really not that many that are bigger than the others.
Yeah.
They're all pretty consistent in that, because there's, that 9.1 magnitude.
That was this one. And talking about, it seems like bunched up on up once you get past the Philippines plate, up here, they're bunched together a lot closer along Japan and up to whatever this is, up to Russia, and then up and across into Alaska. Like they're way, I think they're a lot more frequent in distance. They're a lot more clustered than by the Mariana Trench.
Mm-hmm. So then trends we notice in the data, we talked about some of those things. How do you explain those trends? I don't know if I really did any explaining on them. What would you expect to see if you went further inland? And we kind of talked about that basically the further inland you go, the deeper the earthquakes occur.
Mm-hmm.
That's about all that we see with that. And then what would you expect to see if you did the same thing along the trench near the Solomon Islands? What about the Himalayan Islands? So we did the Himalayan mountains.
Yeah, they're a lot less frequent.
Yep. So that's one thing that I said. Also, we had like an outlier of depth for the earthquakes. Otherwise, they stay between 0 and 33.
Yeah. Yeah, so that's it.
Volcanoes on the original, near the Mariana Trench.
What was that?
Did you see any volcanoes near the Mariana Trench? That's one thing that we did look at the Himalayan mountains. Oh, there's tons.
Oh yeah, yeah. So this is all along that volcano chain that they talk about. This is all the so this is on this side. The right side is the Pacific plate just slamming into all these other plates, and so yeah, they call this kind of just the ring of fire, this volcano chain, that way up and around. So we even have tons of them all the way down here, and then up through Indonesia.
Yeah, there's a ton there. There weren't very many along the Himalayan mountains.
Yeah, so that's something we can say is that since this is a continental to continental, how it's a lot shallower earthquakes and a lot less frequent volcanoes. Because if we look up here at the other to an ocean, the ocean to continental one, up here along the northwest, we have all these volcanoes, and that goes all the way down even into the Andes. In the Andes, we have tons of activity. Yeah, because even looking at this looks like it's even a better example than Japan. This looks a lot more spaced out. I'll turn off the volcanoes, but you can just see how here it's that, and then it's all after that is the 70 to 150, and then 150, and then the 500 are way inland. See that they have all those different size magnitudes in here, and even out here you have these tiny ones as well. So I think that would have been a better example to show than Japan.
Right.
Or at least to throw that in. Cause that, wow, yeah, look at that. Yeah, so now we know the continental is what really causes the shallow ones.
Mm-hmm.
They'll kind of stay consistently shallow. Because those other ones, I think they were ocean to ocean convergeries, and how it was a lot more mixed up than this one. This one, just the consistency of it.
Right. Yeah, you can see those lines a lot better of the depth and whatnot.
Yeah, it's very much segmented up. So hopefully our video and notices us talking about this, because I don't know if we really need to write it down.
Right. I took some good notes. I sent it to you. So if you want to go ahead, if you want to look at it really quick and see if there's anything else that I missed or that you would like to add, so that I can kind of talk with you about it if you do add it, so I can
Okay.
understand better.
Yeah, let me pull it up. So on this fourth bullet point, I'm wondering how to say it, how to word it, because with the first um, from the let's say
Okay, I see. Because otherwise, I'm just talking about the plate in general, and that doesn't really make sense.
or we could word it so it's not the what's the opposite of subducting plate? Do you remember what that is? Okay.
Did you find it? I'm not. I still didn't find it.
I just on the non-subducting plate.
Oh, okay.
Maybe.
What are we looking at? The magnitudes?
Yeah. Just kind of looking at the range because we have some down here in the fours.
Mhm.
The highest one that I found has just been in the sevens.
There is more. It looks like there is more like sevens though. As whereas the other one we're pretty consistent with sixes. This one, there's a lot of sevens. There's a big range. I feel like on these ones, there's not. There doesn't look to be as much consistency as there was the last area. But between, I guess, 6 and 7 is probably the most common.
Yeah. I would. Okay. Yeah, so is there anything else that you want to add?
So I think that's great. I learned a lot.
Okay. Perfect. Glad you did.
Yeah, thank you so much.
All right. So I guess next week at the same time, hopefully Micah will be able to be with us.
Yeah, I hope so. Hopefully he'll look at it and answer the questions and maybe get some of the points if he submits a document.
Yeah, at least try and get scrounge out some points.
Right.
All right. Well, I'll probably same thing. I'll throw the link to the YouTube video on the bottom.
Okay, sounds good. Awesome.
All right. Have a good night.
Thank you, you too.
Bye.
See ya.